In this presentation, we will discuss the construction sequencing of 525 Huntington Avenue. The project gets underway in June 2013. Here we see the green rig used to install the precast in-place foundations, or PIFs. Notice the drive tube and some rebar cages on the ground. Every PIF was installed before excavation began. Around the perimeter, you can also see the sheet piling that was driven before the PIFs were constructed. This slide shows a clear view of the excavator at work, one of the main pieces of equipment for early site preparation. Here's a closer look at the corrugated casings, rebar cages, and the drive tube for the PIF installation. On the right side of the photo, you can see the drop weight that pounds the plug of concrete inside the drive tube. The tops of the completed PIFs are painted green so they stand out clearly. July 2013. Before excavation really got underway, wales and crosslot struts were installed to brace the excavation. Excavators are also visible in action. This is a Gradall excavator used here for digging. Later in the project, it will become especially important when work has to be done under the struts where there's very little clearance. Some damage can be seen on the tops of the PIFs caused by heavy equipment. This isn't a problem since it's above the cutoff elevation. At the center of the photo, you can see a square pile cluster. The piles have been cut to the proper depth with rebar left exposed so it can be embedded in the pile caps. Crushed stone has already been placed. This is a close-up of the top of the piles before excavation reached basement level and before the tops of the piles were cut off. Here's a good look at the Gradall again. Rebar and forms are already set for a pile cap pour in the middle of the photo. Over to the left is a large square pile cluster that will serve as the foundation for the tower crane. Forms and rebar are now set for several pile caps across the site. That large white tank is for collecting groundwater pumped out by the dewatering system. Smaller tanks behind it contain chemicals for treatment because water had to be cleaned of contamination before being discharged. Along the perimeter, you can also see the top of the dewatering system. September 2013. The basement slab has now been poured. Small plywood squares cover the anchor bolts that will hold the steel columns. The bolts sit below the surface of the slab, and once the columns are in place, the voids will be filled with concrete. The water you see here is from rain. Rebar placement for the basement walls has just started. Blue sheets of insulation are stacked nearby, and the horizontal pipe along the sheet piling is the header pipe, part of the dewatering system that collects water from risers. This depressed section of slab in the foreground is the electrical vault, designed with extra headroom. October 2013. Here we see a concrete truck and pump ready to pour a section of the basement wall, though the wall itself is not in view. Note the temporary stairs for access, the laydown areas for rebar, and that the wales have now been removed because the basement slab is strong enough to brace the sheeting. Concreting of the basement wall continues. On the right side of the photo, you can see insulation already in place. You can see that the red base is of the tower crane that has been set. Here, the full tower crane is now installed. Rebar and forms are in place for a basement wall pour in this section. Rebar and forms continue here. The outer face of the wall will be poured directly against the insulation. You can also see a wide view of the laydown areas across the site. November 2013. Steel erection is now underway. You can see the first tier of columns and beams, with metal decking being installed. The second tier of steel erection is in progress. More work on the second tier continues. Bundles of decking sit on the lower level, but because of the very limited lay-down space, steel had to be delivered just in time rather than stored on site. Notice the guardrails and the tool belt worn by the ironworker. Safety harnesses are required, though they're not easy to see in this photo. Work has now moved up to the third tier of steel erection. Temporary bracing in the form of diagonal cables is being used until permanent bracing is installed. Now you can see some of the permanent diagonal wind bracing in the background. The rebar sticking out of the top of the wall will eventually be bent into place and embedded into the floor slab above. Another view of the permanent wind bracing. This beam is being signed by students as part of the topping out ceremony, a tradition marking the placement of the last major piece of structural steel. Here we see President Pantic at the topping out ceremony. January 2014. Concrete trucks and a pump are visible as work continues to cast the floor slabs. Here's a good view of the pump boom and the concrete trucks, along with tarps in place for winter conditions. Here you can see the hammerhead tower crane. February 2014. At this stage, the entire building has been fully wrapped for weather protection. Interior work has started. The orange spray marks on the slab indicate where partitions and doors will go. Here's a clear view of the HVAC ducts and the fireproofing applied to the steel frame. We see penetrations through the CMU wall for pipes and wiring. There's also a stockpile of metal studs with a few already installed in the background. Here the door frames are being set and you have a view of some plumbing rough-ins. Metal studs are in place with fireproofing still visible on the steel frame. Vertical risers for HVAC ducts are also being installed. Now most of the metal stud walls are framed. This concludes this presentation. Please be sure to watch the time-lapse video posted on Brightspace.